Grade 12 Pre-Cal, Lesson 6.4, Graphing Trigonometric Functions. So what we're going to do in this one is we're going to graph the three functions, sine, cosine, and tangent. The most common ones are sine and cosine, but we'll talk about tangent at the end. So a function, again, is a set of ordered pairs, so x and y values. Circular functions are pairs of numbers from the unit circle. So whenever we're talking about the unit circle, which we covered in the last lessons, what we're going to do now is we're going to take those points and put them on a graph. So y equals sine x is an example of a basic function. So we're looking at the y values here, right? So sine is y. So here's, if we look here, we have our x and y's or theta. So on the left-hand side, instead of just regular old numbers, we're going to have radians. And these are the standard ones that we have in a unit circle, right? 0, pi over 2, which is 90 degrees, pi 180, 3 pi over 2, which is 270, and 2 pi. And then we can do just kind of a pi over 4, which is the 45, just to see what it looks like. So what we do is we look at the y value. So at 0, right, our y value is 0. At 90 degrees, our y value is 1. At pi, 0, 3 pi over 2, negative 1, 2 pi over 0. Okay. Well, that really doesn't help us graph that because we've got zeros, ones, and negative ones. But let's put this on a graph. So y is 1 to negative 1 on our unit circle. And then the x values are going to be all our radians. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, we did this pi over 4, this 45, so you can see, oh, yeah, it's right there, 0.707, right? Root of 2 over 2. So what you get is you get a beautiful little curve here. That's a sine curve, and that is the period in this case. So the period is 2 pi, the amount of time to complete one full cycle. The amplitude is the distance from the center of the wave to the top. So for instance, there's the center of the wave to the top, and I guess this way you could also look from the center of the wave to the center to the bottom. It's still an amplitude of 1. So sine, there's a standard sine. And then what we're going to do is we're going to start moving things around. We could squish it vertically and horizontally. We can shift it vertically and horizontally, and we can change different things, but that's coming up. This is just a basic sine curve. Okay, go to the second page, and let's do the same thing, but with a cosine. So we talked already about the period. The period is 2 pi. The amplitude is vertical distance. We wrote that on the previous page, but let's look at a cosine. So again, here's our x values here, 0 to 2 pi, 0 to 2 pi, but we're looking at the x values now on the unit circle. So at 0 degrees, the x value is 1, and then it goes 0, negative 1, 0, and 1. And it's, again, you can see there is a full period of 2 pi. The only difference is that it starts at 1, goes all the way down to negative 1, and back up again. So if you look at the sine, right, the very distinct, starts at 0, goes positive 1, 0, negative 1, back to 0 again. Cosine starts at positive 1. And again, we're going to start doing the other stuff too. We're going to start moving it left and right, up and down, compressing it vertically and horizontally. So again, notice how the graph of cosine is similar to the graph of sine. It's just been horizontally translated. Now, tangent. You won't see a lot of tangent, but we're going to cover it anyways. You'll see it's very unique looking. So the tan value, and don't forget tan is y over x. And when we did this before, we looked at the unit circle, we have undefined points. So we go from 1 to negative 1. Along our x here, we go 0, pi over 2 pi, 3 pi over 2, 2 pi. We just kept going here just to show you what it's like, but we only need one period here. So 0 is 0 over 1, which is 0. Now, here's the big one. Pi over 2 at 90 degrees, it's 1 over 0. That's undefined. So what we have when we talk about undefined is we have a vertical asymptote, right? It approaches that line but doesn't cross it. So then we get our general shape here, and you can see 0 goes up, and then over here, this is a true indication. From negative 1 goes down, right? Negative infinity goes through that point all the way to positive infinity. So we have a couple key things here. Do we have vertical asymptotes? Yeah, vertical asymptotes are at pi over 2, 3 pi over 2, 5 pi over 2. Now, the problem is they go on forever. So you could write that out, or you could do it in the form of an equation. So if you look at this one, x equals pi over 2 plus k pi. And k is an integer, right? So for instance, if it was k was 0, right? 0 times pi, okay, that's gone. So it starts at pi over 2. What if k was 1? Yeah, pi over 2 plus pi. Oh yeah, that gets us 3 pi over 2. And it keeps going. And that also works for the negatives on the negative side over here. What about the x-intercepts? Now, if you look back at the graph, you can see where the x-intercepts are right away, right? 0, pi, 2 pi, 3 pi, right? So there they are right there. X-intercepts 0, pi, 2 pi, 3 pi. Or if you want to write it as a formula-wise, it's just k pi, where k is an integer, right? K is an element of I, which means it's an integer. So 0, right? K is 0, would be 0. K is 1, it would be pi. K is 2, it would be 2 pi. K is 3, it would be 3 pi. And then what happens is when tan is plus or minus x, what happens when we're looking at it? So if you look where tan is positive, and this one is basically tan is negative. So where is tan positive in this case? Yeah, Everything above there, everything above there, everything above there. Where's tan negative? Everything below the line, right? And you can break that down into the key pieces here, which are just points, pi over 4, 5 pi over 4, and then where it's negative 3 pi over 4, 7 pi over 4. So, like I said, the most common ones you're going to see are sine and cosine, and we're going to do a lot of work with those. Tan, you just have to have it in the back of your mind what it looks like, and if you ever get stuck on graphing it, just do your little table of values, and that will help you remember where the asymptotes are and where the x-intercepts are. And then the general shape is always like this right here, general shape. Okay.